Yo, good day. I'm Albert Kendi Mata, an electronics engineering student from Colegio de Muntinlupa. And today I will present my on-the-job training experience with um, Synex Design. So first, I will talk about the lessons I've learned and the skills that I've acquired during the 300 hours training session. So first, I learned about um, stick diagrams. So what are stick diagrams? Stick diagrams are essentially a easier visual representation for a circuit diagram. So it serves as a initial draft for your layout. So I will show you an example. So here is an example of an inverter circuit. So this is the initial circuit and this is the um, final stick diagram. So I will tell you the connections later. So first I will talk about the purpose of each colored line or layer in the um, stick diagram. So the red line is a PD fusion, which is represents the PMOS transistor in the circuit. Next is the green line or green layer, which is the N diffusion or the NMOS transistor in the circuit. So next is um, the purple line, which is the poly or polysilicon, which represents the gates of both the PMOS and NMOS transistor in the circuit. So lastly is metals, which are used to connect the devices together into their correct orientations. So as we can see in the stick diagram, there are some black boxes. So these are connection points in the diagram. It represents the connections between two different layers in the diagram. So next is now I will talk about the connections. So both the sources of the PMOS and NMOS um, transistor is connected to both VDD and VSS. So here are the source of the um, PMOS device. Here in the P diffusion layer, it's connected to VDD. Same here, and the uh, um, NMOS transistor is connected to the VSS or the ground. So both the drain of the PMOS transistor and NMOS transistor is connected with each other. Same here in the um, stick diagram into the output Q, which is here. So both the gates are connected with each other and into the input A. So here is the gates of both the P diffusion and N diffusion of the stick diagram, and it's connected into input A. So since we have a already a stick diagram for an inverter circuit, I will convert it into a layout. So what is a layout? Layout is what the manufacturers use in order to make or manufacture a uh, device. So here is the um, layout design for the inverter. So as we can see, it's almost the same because we already have a stick diagram. It's easier to make a layout design. So the only difference here is in layout, the diffusion layer is color yellow compared to the red and green in stick diagram. So how can we know if it's a um, P diffusion layer or an N diffusion layer? In layout, there are things that called implants. So there are P implants and N implants. So as we can see here, the yellow diffusion layer is covered with N implant or N imp in the synopsis software that we use to make this layout to signify that it's a um, NMOS device. So here there is a P implant, which is the red, to signify that it's a PMOS device. So the connection is it's the same. sources are connected to ground and VDD. The input is in the polysilicon, which is represented in the layout as color red, and the um, drains are both connected to the output. So I will now talk about DRC and LVS. So first, what is DRC? DRC is design rule checking. It verifies as to whether a specific design meets the constraints imposed by the process technology to be used for its manufacturing. So in order for our design to be used for manufacturing or for it to be usable, we need to verify it using DRC and LVS. So first, DRC, um, it is the um, constraints that is imposed within a layout design. So every layer has its constraints or a minimum size. So one example is for the metals or metal one here in the layout, which is the blue metals here in the whole layout. The minimum size or thickness of this layer is 0.14 micrometers, and its spacing within each other is also 0.14 micrometers. So each layer here in the layout has their own minimum size and minimum spacing. So next is LVS. LVS essentially means layout versus schematic. So it checks the connection between your layout and schematic. So your layout will depend on the schematic for the um, connection. So you have to know if your layout connection is correct from the schematic. So you will use LVS as a verification tool to know if what you made as a layout design is correct. So next is the activities that we did during the training period in with Synix design. So first, we made an advanced stick diagrams for our first examination. Next is we made different basic um, layout designs, which are this inverter layout and NAND layout. Next is the intermediate circuits, which is the AO22 and MAJ layout designs. Next is advanced circuit, which is flip-flop. Um, and lastly, for our final project, we were tasked to make a layout for an operational amplifier. So, so for my experience within the um, on-the-job training, my general experience is it's um, pleasant, it's great because the flow of the training is easy to follow and easy to understand for students, and the trainers that teach us are approachable and accommodating whenever we have a question. Eh, and that's it. Thank you.